If you could, when you have a question, please log it into the questions section of the GoToWebinar window. I'll be answering those at the end of the presentation. We do have a lot to go through today. I may or may not show examples for a lot of the stuff, but we have a lot of kind of discussion as it pertains to large assemblies. A few poll questions before we get started as well. I want to kind of gauge the audience and why this is such a popular topic. Now, when we talk about large assemblies, for you in your organization, what do you think is a large assembly? And obviously, it's easy to pick the largest number there, but when it comes to your machines and the types of products you design, what constitutes a large assembly? If you could just vote on that, we'll take a look at where the majority of the group is saying at this point. Okay, we'll give a little bit more time to get everyone voted here. All right, I'm going to go ahead and close the poll and just share the information. As you can see, a good percentage here between 100 and 1,000 components are considered large, and I'm going to open up today 12,000 component assembly with ease. But I want to show you the tools that we use to get those things done. For those of you who are doing 10K plus assemblies, a lot of this stuff is really highly geared towards the top 3 selections here is to make sure the tools get used properly. A couple other questions here. What kind of piqued your interest with this webinar? You can have multiple answers here. What are you trying to get out of it? Are you experiencing very slow large assemblies? Do you have an initiative internally to get better with large assemblies? You just want to find out what's available in the software. And then there's the bottom 2. You attend all the lunch learn, so you might as well jump in on this one and see what's there. And there's a little bit that. And some of you even got free lunch out of the deal. All right, we'll give a second here. We'll go ahead and close the poll and share that with you as well. So, the groups that we're trying to kind of fit this into is obviously the top 3. If you have slow large assemblies, we want to show you the tools to make them better, give you a process to make it better, and hopefully the other folks that are just in here to see what tools are available can initiate those tools for other things. A couple other things that are going to affect some of the way we present today. When you look at your design or engineering group, do you kind of have somebody identified that you would call your Top Gun or your SolidWorks go-to guy, or is it a shared responsibility? Because that does play a role in what we recommend as far as how to implement some of these tools, and it's nice to have that Top Gun in place to kind of lead the way and start the initiative. And I'll go ahead and close so we can get an idea here what we're looking at. It looks like majority of you do have that type of person. Some of you don't. If you don't, as you'll see through my presentation, there may be some benefit to identifying somebody that can become that person. Or you can have multiple people like that. That may work as well. And then just one other tool I'm going to show a little bit later. I want to just gauge from the group how many of you have even heard of the tool called Large Assembly Design Review. The reason I bring this up is it's a tool that probably everybody that does large assemblies should be using. And unfortunately, SolidWorks didn't really put it in a spot that it's easily aware and easily usable. It isn't kind of right in front of your face, so we'll talk a little bit about that. So as you can see, a majority of you have not seen or heard of that tool, so we will cover that as well. So let's go ahead with the presentation. A little bit about the computer that I'm running on today. This is a Dell Precision M66 laptop with Windows 7 64-bit. It's got dual quad-core i7s clocked at 2.4, so it looks as if it's got the 8 cores within the system. It has 16 gigabytes of RAM. Quadro FX mobile card. It has a gig on the card, and I'm running SolidWorks 2013 SP2. So if there's any question about my performance versus maybe something you're seeing, we can compare it to the hardware specs. I'm also running a solid-state hard drive. Solid-state hard drives are known to be up to 10 to 100 times faster than a spindle disk. The issue with a solid-state hard drive is they don't start to go. I mean, a spindle, you might hear your hard drive getting noisier, and you have time to back things up off that hard drive. With a solid-state drive, it's like a flash drive. It just stops working. There's no recovering the data when it stops. There's some risk associated with that, but if you're using some of the other tools that we have, that won't be such a risk, and you may be able to go to a solid-state hard drive when you spec out some of the new computers. So what our topics are today, we'll talk about what is a large assembly, and I've asked some of that question to the group already. What are the symptoms? What affects performance? And then I want to break down what it is we can actually do. And in the end, I want to talk about what we see as an implementation strategy. There are some resources out there that I want to kind of point you to as well. So what is a large assembly? And really the answer is different for everyone, as you saw by my poll question. It's really anything that can either A, max out your system resources, or hurt productivity. And I got a nice little video here that I want to just share with the group. I don't know if you've seen this. It's kind of old. It's the OCC guys using SolidWorks, and I'll let hear the audio here. You ever got this type of frustration with SolidWorks because of large assembly? You'll see what he does here. So this video is out on YouTube if you want to take a look at it. It's from the OCC folks. So the answer is really different for everybody of what a large assembly is. If it's hurting your productivity, then it's large, plain and simple. So symptoms of a large assembly, you're typically going to have slow open and save times. Your rebuild times are slow. Maybe you're waiting for drawing view creation, or something as simple as just panning, zooming, and rotating is slow to you. Assembly meeting can also be slow. Anytime you're waiting for that system to solve, slow performance, that's the symptom that you're going to see, which we would say a large assembly. Now here's the reality of the problem. Things under SolidWorks control, things that SolidWorks affects, is really only about 30% of the problem. Things that you control are really 70% of the problem, and that's what our conversation is going to focus on today. What can you control in this scenario? Obviously, you can't make the lines of code in SolidWorks faster. You can't make changes to the software to do it a different way. But what you can do is what I'm going to provide you with today. When you combine the SolidWorks technology with the correct implementation, you kind of become a control freak. If you have this process in place, you can severely affect your performance in a positive way. So what can you do to manage large assemblies and drawings? First of all, things that are under your control, things that you can do. First of all, the software settings or general settings in the software. We're going to go over that. We'll talk a little bit about hardware and things that are going to be affected there. Part design techniques, assembly techniques, drawing techniques, and I put this as the last one, but I really think it's the first one, your environment and the data management and how you access and modify the documents, whether it's over the network, and what else is in that environment also play a huge, huge role into your experience with SOLIDWORKS. So let's start with just some general settings. Everybody knows where Tools Options is, but under Tools Options Performance, SOLIDWORKS has kind of put a lot of the standard options that affect the speed and performance of SOLIDWORKS in one spot. Okay, this is where I would start to go and create a standard. Now, we talked about identifying a Top Gun or SOLIDWORKS user. This is one of the first places I would start, is to make sure everybody has the settings set the way that you want. One I'll bring up automatically is the very first one at the top that's called Verification on Rebuild. If this is on, it enables this advanced checking of parts, and it can severely slow down and hamper just opening parts and assemblies. You kind of want to avoid that. Level of detail. The more detail you have, the slower it's going to be. You can turn off some of that detail while you're panning, zooming, and rotating. Also, things that we're going to discuss today, like lightweight components and animation speed. All that stuff is in one spot under your general settings. So my recommendation is to create a standard. Make sure everyone's on the same page as it comes to settings. Now, there's one setting that I would say go after right away. In Tools Options Performance, there's an option to turn off the preview during open. So when you open a large assembly, the first thing it's got to do is load all the graphical data, because if you haven't noticed, you can actually pan, zoom, and rotate before the model ever gets fully open. Now, I've been doing this a long time, and I can count on one hand the number of times I've needed to pan, zoom, and rotate before the file is actually open. Not to mention, it's not exactly the speediest pan, zoom, and rotate, because the system is still processing information. Now, a little bit about the hardware. I mean, hardware does play a role in the quality of how your large assemblies are going to run. I would say make sure, first of all, that you've met the SOLIDWORKS system requirements under solidworks.com. If you're running a 32-bit machine today, it's too slow. It can't access enough RAM. You really need to be on a 64-bit machine with 64-bit operating system. I know SOLIDWORKS supports 32-bit, but 64-bit is the way to go and where you need to be. When it comes to multiple cores, like my dual quad core, just wanted to remind everyone that there are some tools in SOLIDWORKS that do support the multi-threading, things like photo view, the simulation and flow simulation tools, your file translation, and something as simple as converting high-quality views on a drawing or hidden line removal. That will support your multi-core processes, and hopefully in the future we'll get a little bit more of that. So, you know, getting a multi-core machine is nice in general because of all the different speed that you'll gain being able to run multiple things at a time. When it comes to the video card, really my recommendation is, first of all, just make sure it's certified and tested as to the SOLIDWORKS cards. But you know, another thing you want to consider with the memory on the card is, what are you actually pushing out? You know, I've seen folks running as big as 42-inch monitors or TVs off this thing. And depending on the resolution, you may be pushing the memory on that video card as well. If you're pushing that, it might, again, affect your pan, zoom, and rotate speeds, your quality of refresh rates on the screens itself. If you're spanning screens, you know, just make sure your card is going to be sufficient enough to handle that. And there will be some notes within the certification and testing and the video card page to help you with that. Now, I may get some flack for the last one here because I know it's a little bit hard to stay current on service packs. But if you stay current on service packs, you have the latest speed and fix tools built into it. It's always going to work the best with the operating system. That's not to say that you won't, something else may not break along the way, but staying current, at least on a certain release, gives you the best chance of avoiding other issues with that. So I do recommend staying on the most current service pack. Let's talk a little bit about design methods. You know, how you design your parts are important as well. If you create parts in context of an assembly, do you really need to? Okay, when you create parts inside of an assembly and you create relationships between parts, you're basically telling me that that part is unique. It's one-off. It's always going to be related. It's not going to be used in other assemblies. That's fine, but make sure that's the case. Don't use in-context relationships unless it's appropriate to do so. Now there's other techniques like using master models, you know, inserting a part into a part and using that as your start part, or skeleton modeling where you start at the assembly level with layouts and blocks and creating you know, all your parts and assemblies referencing this sketch and layout. All of these are appropriate as long as, you know, the geometry warrants it. You want to think a little bit about what method is best in this case. It's important. Okay. A couple things that they've added in 2013. I'm going to show a little bit of this. Talking about configurations, and for those of you who haven't seen the option to open parts using Quick View. Now when it comes to configurations, when you load a file, if you're on previous to 2013, as soon as you activate a configuration, it loads all the data for that configuration. So let's say you've been sitting up with a file most of the day and you've loaded, you know, half the configuration, 6 or 7. Well, now you have what's equivalent to that part open 6, 7 times because all the configuration data is currently loaded. Well, they've added some tools to actually purge the configuration data to get it out of memory. They've added an option to set a rebuild or save mark. Now what this means is if you've ever had the issue where a configuration is out of date because it hasn't went back to the part and rebuilt that configuration, it only typically does that on the active configuration. What this does is allows you to create a save mark, so every time you save the assembly, it updates the most important configurations. Now where that's going to help you later is as you start to load more configurations of sub-assemblies and on your way up, it will already have the data, won't have to unload and reload. And then Quick View for quick viewing. I want to show that as well. So let's start with the Quick View for a moment. If you do a file open on a part that happens to be fairly large, there's this mode box in your open dialog. If you haven't noticed this, this will become an important part of our conversation today. But I have the ability to select Quick View. And notice some of the options kind of disappear here. But what it does is it just opens the graphical data for the part. And I immediately have the ability to pan, zoom, and rotate. Notice I have no feature tree. So it's almost like opening it up in the viewer, but it's even faster. So if you've ever just wanted to, or had somebody come by your desk and, hey, can you open up such and such a file? And, I want you to take a look, or I want to show you a few things. Well, if I open it up and it rebuilds the features on open, this could take a minute, 2 minutes to open. But if I use Quick View, I can go ahead and get it immediately open and have the ability to go ahead and reuse or at least look at the information. Now, when it comes to configurations, you're going to see some new things using 2013. Next to the configuration, any configuration that's loaded into memory will have a check mark next to it. Any configuration that you want to save the updated data at each save will have this little disk next to it. Anything that is not loaded will have the dash. Now, how do I add a disk to any of these? Let's say this is an important configuration I'm going to be using. I need to make sure the graphical data is up to date. I can right-click on it, add a rebuild or save mark, and when I save the assembly, it automatically goes and updates the most current data for each of those. So you don't have to worry about an update at the assembly level. If I activate a configuration, now in 2013, it now becomes loaded into memory. See a check mark under both of them. And you can see as I flip through these are now loaded into memory. Now if you're working in a large assembly and you've loaded a lot of configurations, again, you're taking some of the power of your equipment out of play here. So one of the things you do have the ability to do, if you right-click on the Configuration Manager, you can actually remove the mark and purge data for all configurations. So I can purge the data on the configurations, getting it out of memory, getting it out of use for SOLIDWORKS, and only having the configuration that I want loaded. Again, when you're flipping back and forth and working with large assemblies, this can be invaluable. Okay, continuing on. I want to stress this portion of my presentation quite a bit, because in order to improve part performance, there's a few things to consider. First of all, fully define your sketches if possible. Don't leave it up to the software to decide whether or not a line can move because you never restrained it. Use the right-click fully defined sketch to restrain something if you're questioning what restraints or dimensions you need to locate anything. Resolve your rebuild errors. Every time a part has rebuild errors, it's got to chug through that on opens, on rebuilds. It's got to present you with the data. It adds time to your parts. An example in general, do not model your threads unless absolutely necessary. And then taking a look at using text for features. Now, I bring these up, and let me go in here to a folder. So I have a folder with a bolt. This is just the example that you see on the slide here. I have 3 different versions of the bolt. Let's go ahead and open these up. But look at the size. The third version is almost double the size of the other 2. So this is what we have for the 3. The first version is just a shoulder bolt with no threads. Okay, so the shank is the diameter of the threads. This is what we're typically used to. The second one, we've modeled them with cosmetic threads, which are nothing more than revolved cuts and a pattern. And the third one is actually modeled threads. Now let's think about this for a moment. I've doubled the size of the part file between the first and the third just by adding modeled threads. If I look at the feature statistics, you'll notice it takes a half a second to solve the cut sweep. Now let's say you have 400 of these in the assembly. How much more time is it going to take your assembly to solve some of this? If you have multiple different types of fasteners, are you adding 30 seconds, a minute to it? Now let me also ask you this. If you have a large assembly and you're putting these bolts into that assembly and you create a drawing view of it, are you even going to see these threads? You're not even going to see them in the assembly drawing. So why do you need that level of detail in the assembly drawing? When I see extruded text, let's see here, something like this, it seems harmless, but I've seen so many times somebody gets me a large assembly and I'm zooming down in the components and I find a cap or a cover that has a manufacturer name extruded on it. It looks fantastic, but it doesn't help you with large assemblies. If I look at something like this and look at the feature statistics, it takes almost a full second just to rebuild the extrusion of some basic text. Do that 5, 6, 7, 8, 9 times inside of an assembly, and guess what? You've just added 10 10 seconds, 30 seconds to your rebuild times. Okay, something to definitely consider. Okay, I say avoid unnecessary detail. And I'm going to show you a different kind of approach here in just a second. So here's my my message here: simplify, simplify, simplify. Here's what I'm going to recommend that you do. Take your templates, maybe after today, create a new part from your templates, and go into every template you have and add a configuration called simplified. Now, by doing this, every part I create has a simplified configuration. So as I start to create geometry, whatever that happens to be, okay, and I go to add other features that maybe aren't necessarily in the assembly level, I can go to the simplified configuration, okay, and only have it have the features that I need for the large assembly. Okay, so you simplify each part as you're designing it. Don't wait to the end. Nobody's going to go back and simplify everything you already have in assembly. The time to create simplified versions of parts are as you're designing them. Okay, every part you create should have a simplified version that can be utilized in the assembly. I think it's super important to do that. And I would just save it right with your templates so that you can go ahead and go from there. Now let's move on to some of the assembly stuff. It's important when you start to lay out your upper level assemblies to think about how SolidWorks solves assemblies. The first thing it solves are all the parts and assemblies or sub-assemblies inside the upper level. It then has to calculate the time-dependent features, if you've ever heard of that. Time-dependent features, it just means they can't be solved until all the components are in place. It has to solve the mates. After it solves the mates, it solves the component patterns. And then there's assembly-dependent items at the bottom where you've updated sketch, you've added planes. Now think of this scenario. Let's say you've mated to a component pattern. Well, now we rebuild the assembly. It rebuilds the part. It rebuilds the mate. It rebuilds the pattern. Well, because it rebuilds the pattern, it may trigger the mate to rebuild again. Well, guess what? A rebuild just goes one time down the tree, right? One time in order. Well, now you're going to have another rebuild flag on a mate or on a component. Okay, you might have to do multiple rebuilds. If you've ever had to do that, you probably mated to component patterns or assembly-dependent items. Okay, so you want to try to avoid mating to those two things. Now, the types of mates also affect your performance. Now, the last thing I want to preach here is for you to avoid using other mate types. I think it's important to see things like limit mates and distance mates. But if you're dealing with a large assembly, there may be a way to do that with configurations. Let the configuration you can have different mates per configuration. So the fastest mates are going to be the relation mates, coincident, parallel, concentric. Those are all the fastest. And followed by your logical mates with width, cam, and gear. Distance and limits mates being the slower of the four categories. Now, it's also faster to mate to a common reference versus mating to a chain. Let's say you're putting 4 bolts into a plate. If I mate the first bolt, the bottom of the head of the bolt to the top of the plate, coincident, and then I decide to go to the next bolt and make that coincident to the bottom of the previous bolt, I'm chaining. I'm making a reference off the last set of mates that I've done. If you can create a common reference, try to mate as many things off the same reference, for instance, all 4 the bottoms of the heads of the bolt all to the same surface, it's going to be faster. Okay? And these are things we want to think about implementing as you move forward in large assemblies. A tool called the Assembly Expert. This is where I go to get a good look at what I might be able to do to help my performance of an assembly. It's found under Tools Assembly Expert. This tool can actually make advice or give you advice about your assembly. Now, it also does diagnostic tests. Okay, it can tell you whether the latest the files have been built in the latest version of SolidWorks or they need to be converted. It can tell you how many mates have to be evaluated in that assembly. It can show you, whether your display speed is slow. It can tell you if your components are too far away from the origin, or you've turned on verification on rebuild, or conflicts between relationships. This helps you out. This is where I go with all large assemblies. So let's take a look at that for a moment. Let's see here. Opening up an assembly. I don't know if anyone's ever done this, and you hit zoom to fit on the screen and it's still blank. Well, here's where the tool will come into play. Assembly Expert under the Tools menu. Now, the X's are not necessarily an error. It's just kind of a warning to let you know that that might be affecting you. It says 4 of the 18 documents have not been updated to the latest version. If you're constantly opening assemblies that have files that are 2009, 2008, earlier than that, it has to convert them to the format every time you do an open. Well, that's going to slow things down. So if you have all the files updated to the latest version, it's important. I can actually get the little glasses here and actually see which components need to be updated. Okay, I can then save this to a list or isolate the components. I'm going to talk about isolate a little bit later to make sure I can get those to the latest. It tells me the number of components in the assembly. Okay, in this case, one of the components is very far away from the origin. I'm going to show you this in just 1 second. How many mates are being rebuilt at the upper level? Well, 42 mates. The less mates we have to rebuild at the upper level, the faster it's going to be. I'm going to show you a good example of that also here in a moment. Okay, so a report of the last assembly rebuild. What this does is it shows you a report of, let's go ahead and show, the time that it's taking to rebuild different things within the assembly. Okay, the casing full rebuild time, rebuild pass, assembly features, what time it's taking. And this is in milliseconds in this case. Okay, so it does give you some indication in that sense which ones are taking the longest. And then at the bottom is just kind of a summary. How many parts, how many unique parts, how many levels and sub-assemblies do you have, how many top-level mates and bodies are we dealing with. Now, as I said, it can also help you to fix things. See this little wrench here? I hit zoom to fit and nothing showed up. But if I hit the little wrench, because one of the components is far away from the origin, the software actually is going to move that component closer so I can now handle and deal with it. So the Assembly Expert is something that you want to go to and kind of work with. Now, what should your assembly structure look like? Now, this is just a general example of what an assembly structure should look like. You can see how quickly that opened up. Now, there's some reasons behind that. It's not all just because of the way it was built. But if I start expanding the tree on this, you can see that everything is built in sub-assemblies with multiple levels. And if I go to the top level and I look at the number of mates, there's only 2. The software only needs to solve 2 mates at the very highest level. So if I come into my Assembly Expert for a moment, let's take a look at how many components. there's actually 12,000 components in this particular assembly. Now, part of the reason it opens so fast is because there's only 3 unique parts. So don't think that your 12,000 components can open this fast if you set up the level, but you're certainly going to speed up how quickly it opens and saves by doing this. Having the least number of top-level mates possible based upon the structure that you need is also important. Okay, so using Assembly Expert maybe going forward would be a recommended best practice. Okay, a couple other things to note here. Subassemblies are fixed by default. So when you solve an upper level assembly, it does not solve the mates for the subassembly unless you make them flexible. Now here's another recommendation. If you need flexible subassemblies to be able to solve motion, don't leave them flexible. Turn them flexible, show the motion, whoever you're showing with it or in the drawing, and then make them rigid. Okay, always save your large assemblies in rigid. You can always toggle them flexible to solve that. Otherwise, you're adding all the mates from the subassembly at that level as well. A couple other things, and I'm not going to spend a lot of time on this because it's no longer the prime tool. There's something called lightweight assemblies. It loads a subset of data in SOLIDWORKS. You can turn it on automatically by specifying large assembly mode and in the tools options performance that I said earlier. Let me just show you real quick where that's located. If I wanted to open a large assembly in lightweight, it's listed under this pull down menu for mode. Okay, and what this would do is load just a subset of the data inside of SOLIDWORKS. Okay, I would recommend going to the help to get all the details, but you can still do a lot with this, but this isn't my recommended method anymore. You can also turn it on and off by using what we call large assembly mode. It's under your tools menu. That will start to load things lightweight for you. Okay. Now this is the tool that I asked about at the beginning. This concept of large design review. There are tools out there in the industry that are there specifically for viewing large models, but also giving you the ability to review it with extra tools with other people. And SOLIDWORKS added this a couple of releases ago called Large Design Review. You have some extra capability. First of all, it is the fastest way to view an assembly. If you have large assemblies and you need to show somebody something, open it in Large Design Review. Now from there, you can open only the components you need to work on, what we call selective open. You can also hide show components. You can section, measure, add walkthroughs, take snapshots. There's a lot of things you can still do by entering into this mode, and I wanted to show you a little bit of that. All right. Let's take this assembly here. If we go ahead and select Large Design Review, you can see that's right in the Open dialog. Now it also brings up this little screen to give you an idea of what you're capable of doing in this particular tool. If you say don't show again, it will not pop up any longer. But you can see how fast that it just opened this assembly. Okay, it opens it real fast. What you don't get is the full feature tree. You get each component, each subcomponent, all the graphics for those components, and you have a single toolbar at the top that allows you to do other things. I can go ahead and measure in the assembly. I can cross-section, and it's very fast. Okay. I can go ahead and look at the assembly statistics, assembly expert information. I can take images. Okay, so copy and paste images to other documents. How many times have you been sitting at your desk and had somebody walk by and say, hey, can you pull up such and such an assembly? Well, then you go to open up the assembly and you're sitting there and you're waiting and you're waiting and you're waiting because you're loading it fully resolved. Well, with this, it's going to open up instantly. If you're using this just to show prospects or show customers maybe some designs that you have, there's something we call walkthrough. Walkthrough, I don't know how well this is going to come through on the GoToMeeting here, but it's like having a video game controller on your equipment. I can, look up, look down, look right or left. Okay, basically turn my head, left and right, and I can start to walk through the product. Hopefully this is coming okay. But essentially you can walk around your product to get a visual cue. You can also record the video and save this. And again, I don't have the full model loaded. Well, what if I do need to load something, right? I'm going to now work on this assembly. Well, they have a tool called Selective Open. I can open it selectively using lightweight mode, which I want you to kind of review a little bit, but if I want to open it fully resolved, I can tell it which components I want fully resolved. I'll pick maybe this subassembly and tell it to open the selected components. Well, now this component is fully loaded at the assembly level. I don't have to worry about all the mates and all the other overhead. Everything else is hidden, and it only loads what I need to make any modifications. Now I can edit the component, I can go ahead and make the changes that I need, but I only have what I need. If I need something else, I have an option on my assembly toolbar to show hidden components. And let's just say I pick a single component here. When I exit show hidden, it's going to load just that component, okay, into memory. So I can load and unload what I want. So I'm only working on the pieces that I need to work on. Okay, I think very, very important. All right. Another one that's been added, and I think is a tool that should be initiated almost immediately if you're doing large assemblies, is something called SpeedPack. SpeedPack allows you to create simplified versions of assemblies and subassemblies without losing all the graphical detail. It definitely reduces the memory needed. It still maintains all the references. It works with drawings. Okay, all of this is important. So what's SpeedPack look like? All right, let's open up a couple assemblies here. All right, I need to put this assembly in the upper level, or sorry, this one. This assembly into the other assembly. But as you can see, I have several components to it. I have a couple sub-assemblies. I want to eliminate the need to have all this data in the next level. So if I go to my configuration manager, what I can do is add a SpeedPack. Now, what we're doing with SpeedPack is telling the software what information I need available to me when I go to place this subassembly in the next level up. Well, I know I'm going to be mating this face. I also know I'm going to use the holes on the four corners of this assembly. So I want all of this stuff loaded into memory when I go to that next level. Now once I create the SpeedPack and I mouse over the assembly, you can see this little ghosted image. It shows me what it is that I have loaded. And you do have the ability and options to turn off this kind of ghosting circle. So it just looks like the full thing is fully loaded. Now it does act as a configuration of the assembly, okay, without a problem. Let me just go back to the full assembly for a moment just to show something else. You can do this to sub-assemblies as well, even from the upper level. So what I can do, if I pick on a sub-assembly, I can create a couple different SpeedPacks. One is called a mated SpeedPack, which will only load the faces that are used at this level to mate it up. Or a graphic SpeedPack, which is unload everything and only have the graphical data. Okay, you can see that my ghosting says it's almost eliminated, but I can still see it. Okay, so these speed packs are important. So now how do I now take this data to the next level, right? I'm in here to the next assembly, and you can see this is speed packed as well. As I ghost over, not all the faces are included here. Well, I want to go ahead and insert this other assembly in here. And now, because certain things are loaded, I can start to mate it. I want this face to this face, and I can only mate to the faces that are there, right? I want to make sure I flip it the right direction. Now, as far as moving it, I just have to grab the faces that I need, and I can now mate up the holes because those are loaded as well. Now, let's say I forgot a face. You can always go back and edit the speed pack to add faces to it if you need to. But now I'm sitting at an upper level assembly that's pretty good size, and I don't have near the amount of data loaded into place. Now, if the components change anywhere along the way, you can see that you'll actually get a little option saying the speed pack is out of date. What you can do is use the option to update speed pack, which will go through and reload the data that it needs and update everything. So you do have the ability to get all throughout the process with this. Another thing that's also important, I can now take this assembly speed packed, and I could send the assembly to someone without sending any of the parts. Because you'll notice as I expand this, none of the parts are listed here. So you could literally send this to somebody else using SOLIDWORKS, and it will only contain the data that you speed packed. Something to think about. Okay. Okay, we're getting a little bit slow on time here, so I'm going to get a little bit faster with some of the things we're going to show. Display settings. Only things I really want to bring up here is, first of all, real view graphics with large assemblies, make sure it's turned off. Okay, it just adds that performance hit for real view graphics. The fastest way to view a large assembly is going to be shaded without the edge display, which is going to be my first. The second one that's going to be the next option up is your hidden line removed. After that, if and most of us do, use shaded with edges. Shaded with edges is going to give you the most performance hit. Okay, just keep that in mind. Using display states. If you're not aware of what display states are, they should replace configurations for you if you're just showing and hiding or displaying parts differently between configurations. The reason is they never require a rebuild. Okay, so let's just real quickly show what that looks like. Let's close some of these down here. Actually, we'll open that one back up. So I need to show on a drawing a version of this without the housing. Well, a lot of times what people are doing now is they create a configuration and then they hide or suppress the housing. When all you need to do is use display states. At the bottom of your configuration manager, you have the option that shows what display states are available. Now you have the ability to add a display state in here, and I can rename those display states. I can call this without housing. Now what I'm able to do now is if I go to the feature tree and expand the display pane, I now can control things like whether it's shaded, hidden line remove, whether it's hidden of these components. So now if I select my component here, I can go ahead and say, you know what, let's make that wireframe in this case if I wanted to, or maybe I want it hidden. Okay, I can go ahead and hide that. Now that isn't a configuration. All I have to do is flip back to the other display state and it shows. The great thing about this, they don't require rebuilds. Okay, so if you're creating configurations just to hide the show or vary the visibility of components, I would recommend getting to use display states. When it comes to external references, we know that we can create them inside the assembly. I want to be clear that you want to make sure you fix broken references. Okay, if they're missing or they're broken, it's slower than versus going and actually removing the references so they're no longer broken. I know we can break them now, but we want to make sure that you go back and do the fixing. The other one is just a tidbit about electrical routing. If you're doing any of that and you're doing pin-to-pin connections, that's a little bit slower as well. Because of the references being created by doing so. This could be a whole lunch and learn to itself. I showed you a little bit with Large Assembly Design Review how I had the ability to load the components that I want. Well, there's a whole set of tools that kind of goes with that that allows me to load and unload parts, but also uses selection techniques that we have to help us with that. Now let's show a little bit of that. I'm going to pick an assembly here. It's not a huge assembly here, but I think it'll get the point across. So a couple things here. Let's say I wanted to start hiding components, right? Well, I could manually go and start hiding everything that I don't want to use. Once I hide them, I'm usually searching the tree to show them again, and that's not very hard unless you got a really complex tree, right? But there's an option to show hidden components. What this does is it only shows what's hidden, and then you could select on the ones you want to show again, and they'll now become shown. You don't have to search the tree to do that. The other neat tool for this, let's say I picked all these components over here. If you pick a bunch of components, what you can do is right-click and isolate them. Isolate is a tool that's added in here that basically just eliminates and only shows the parts in the graphics area that you want to use. Now I can also save this as a display state, which is really neat. Once I exit isolate, everything else shows back up. But what if I selected all these components and I really just wanted to hide all the rest? Well, what I can do on my right click, there's an option called invert selection. Now everything I didn't select is now selected, and now I can right click and hide from here. Okay, so you can do a lot of different things just hiding and showing the pieces that you need. Okay, if I wanted to show all components, very simple. I just window select everything, they all show. Okay, very simple. Now, what if I wanted to go through my assembly and at the upper level I didn't want to see any of the toolbox parts? What I can do is under my select command in the pull-down menu at the top, I have the ability to select things based upon some unique tools that we have in here. First one we'll call the volume select. I can just draw a window and now I have this volume that I can use to select items. So everything fully within the volume. If you create the rectangle going the other direction, it's everything crossing the volume. And now I can come in here and tell it to hide or isolate from there. Well, one of these set of options is something called Advanced Select. Now this is where you can create your own search criteria. In this case, and look at all the options in here. I can search on custom properties, I can search on component status, display, configuration names. Well, I can create one of these and save it as a name, and then now becomes a managed search. Well, when it's a managed search, I can now use it in the pull-down menu. Here's the one I called Test. But there's one built in here called Select Toolbox. Now what this does is it selects everything that's a toolbox component, and now you can right-click and isolate them, or right-click and hide. Okay, so great way to kind of get all those toolbox components and create a configuration that you no longer need to see them. Okay. I think I showed most of this. A couple other things: filtering and tagging in the tree. Let's just show this real quick. Let's say you had a bunch of washers in here. What if I typed in at the top of the tree washer? And now I can come in here, go ahead and select all the washers and hide them or isolate them and do something else. All it is once I delete the text in the filter, it goes away. They have also in the bottom hand corner something called tags. Tags, you can put other text data to components. So I can add a tag for a component, and there's a bunch of stuff in here, and we'll just call it dial spacer. And as you type in that, it sorts the tag as well to give you components. Okay, so a couple other extreme assembly management techniques. There's an option in Assemblies to do not create references external to the model. So I can build parts inside of an assembly but not create references. A lot of times you want to make sure it fits, but you don't want references. It's a great way to do that. It's under Tools, Options, External References, or it can be added to the assembly toolbar. Another one is suspend automatic rebuilds. When you're working in a large assembly and you make changes and you exit out of a part and it takes 3 minutes to rebuild, well, why don't you just turn that off? If you right-click the upper level of an assembly, you'll see an option, Suspend Automatic Rebuild. That turns it off, and when you deselect it, it will rebuild when you're ready, not when it chooses to do so. Now the last little bit we're going to show, and then we're going to get to the close here. And I can provide anyone with the presentation if you want to see the rest. But all of these tools go to drawings as well. Drawings have this whole concept of being able to quick view as well. If I do a file open on a drawing here, you can see that I have the option to open it lightweight. I can open it in quick view. Quick view for drawings is awesome. Again, if you've ever had the need to open up a drawing really quick to show somebody, but I can also select which sheets to physically open. So maybe I'm working on one particular sheet here. Well, in this case, I don't want either of the sheets to load. What happens is it essentially loads things almost like a PDF. So I have an image of the drawing. I can pan, zoom, and rotate and get the detail and everything that's there, but I don't have any tree for the drawing. I can also mouse over the other sheet and get a preview, or select on the sheet and get a preview. Now when I want to physically load the sheet, I can use and load one single sheet at a time, or I can load all sheets. Okay, quick and easy, nice way to work with drawings. Maybe you set it up so you use quick view all the time and only load what you need, especially with the large assemblies. Okay, I'm going to skip over this for a moment. And one of the things I mentioned at the very beginning was the environment, and this concept of working across the network and having a document management system in place. I can't stress enough how much this really affects your performance. There's so many things that are part of the architecture of your internal organization, switches and routers, and all of these things are going to play a role into how well your solver performs. Because as the part's open, if it's open across the network, it's communicating through switches and routers and all the way to the server. And if just one bit of information gets messed up along the way, that could be what's causing your issues. Slowdowns and locking up and crashing. So really the best answer for this, and I think everyone needs to get here, is to put one of the PDM systems in place. It doesn't matter which one, workgroup or enterprise PDM, but it's going to allow you to work locally on your machines. It's going to bring the data down locally. You're not communicating across the network for the whole time you're making the change, and when you're done, you put it back. And you really are going to eliminate a lot of possible headaches along the way. Now, to finish this off, I just want to talk a little bit about a strategy for implementing these. And I've shown you just a bunch of tools, and they seem to be in all sorts of different areas of using SOLIDWORKS. So how do you get a handle on implementing all these tools? Well, it really comes down to creating a best practice for your organization. Number one, you want to identify a power user. Identify that person that's going to help investigate the tools, figure out which ones are best used in your organization based upon different processes and things you have. To do that, this link, and you can send me an email at kevin@caddimensions.com, actually has a self-study book for handling large assemblies. SOLIDWORKS put this out. And it goes through all the tools that I covered today, plus a lot more. Project planning, laying out your assembly. It's hundreds and hundreds of pages, and this can be used as a great resource. Number two, put a PDM tool in place. Start to work locally. It's going to make a big difference in your organization by doing that. Okay. When it comes to creating your best practices, it's best to organize them by areas of improvement, because you can't just say, okay, tomorrow we're going to do this in drawings, this in parts, this in software. Start in a certain area. Say, okay, let's look at our component design methods. And tomorrow we're going to start to create simplified configurations of all our parts. And that's our first part we're going to implement. And the second part, we're going to make sure all of our software settings are optimized for performance of large assemblies. And then we implement some assembly design methods. And we make sure our hardware is in place. And you take it in a step-by-step approach, but you create some sort of best practice so you can repeat it. You have somebody new coming in, this is how you do things. We create large assemblies, so this is what you want to do. Okay, it's important. So I want to thank everyone for attending today. I apologize we went a little bit over. I do have a few questions. We can go ahead and go from there. What is the alternative to extruded text when text is necessary? So here's what I'll say about that. If you need text on a part drawing, then put text on your part. But if that part goes into the assembly, create a simplified configuration so that text is suppressed. Because in the assembly, you don't need to see it. 99% of the time when you create drawings or you're just viewing the upper level assembly, you don't need to see that text. Now, if you do need to see that text in the assembly, create a configuration of the assembly so that that part isn't loaded with all the text all the time. So you can simplify it all the way up through the process. Somebody asked also, will the speed pack update if you change the part? I think I did get to that. You do have an option to update the speed pack. Can display states be locked so other people in the team can't mess them up? No, I don't believe display states can be locked. If you have access to the file, you would have access to changing them as well. Resolution settings. Someone asked about resolution settings. And again, this is gonna play a hit here. Oh, let's see. I just gotta find it. Let me open a part here. All right. Now, best way to find something in here is do your image quality and resolution settings. So under document properties, you have this resolution option. And I think this really comes down to personal preference about how, what's acceptable for you for visualizing. If this doesn't affect the drawings or the printing of the drawings, it's more as you start to visualize and design, how much deviation can a circular edge have to make it tessellated? This is too much, right? It's going to increase the file size. You're going to have a lot more information in there. As you saw, mine's down here pretty low. I would say, if you're doing large assemblies, you're going to want it low. If you're finding that you're getting to looking at parts and the tessellation of the edges is really bothering you or having trouble making selections, then go ahead and make your changes, and that should help you out. But you're going to take a little bit more of a hit as you do that. Continuing on, any way to speed up the handling of large imported generic files like IGES and STEP? That also is in my presentation and in the book as well. It talks a lot about that. The key to those files, first of all, is to make sure they come in, they're repaired, and they're healed. Now, once they're repaired and healed, what you might want to do, depending on the level of detail that you need for those components, you may want to even simplify it yourself. Extrude features over the top of other features to eliminate the number of faces that are needed. There's also a tool called Tools Defeature that you may be able to use to remove or eliminate features that you don't want to show on a part. Again, it's the number of faces in the graphics part of it that it's usually slowing it down. And if you have not converted it to a solid model and cleaned it up, that's going to be even slower. So, number one is to get that cleaned up. What about turning your threaded components into dummy solids? Will this help the rebuild time? It's not really going to help. It may help it a little bit, but what happens is it's really the number of faces that gets created by turning the threads that adds more time to the calculation. You're going to remove the amount of time that it takes to rebuild the feature, but it still may take just about as much time to calculate the graphics for a complex thread with all those surfaces. So I would create a simplified part and have one with, one without, and do it that way instead. Will we be automatically emailed a copy of the presentation, or do we have to request that? If you wouldn't mind just requesting that, it's a pretty good sized presentation. That will be a little easier, and it's just kevin@caddimensions.com. Another question, do components that are not fully defined in an assembly take longer? Or a bolt that can spin? Great question. Because the time that it takes to solve a mate affects the speed in which assemblies rebuild, components that don't have mates are faster, right? It doesn't have to solve the mates to position them. So if they're kind of floating in space, it's fine. Now, you can't have that because components will move all over the place. Someone can actually grab it. But the example, can a bolt still spin? Absolutely. If you put a bolt in a hole, there's no sense putting a third mate on there to lock down the rotation. Leave it there. Okay, adding that extra mate is going to slow it down. Okay. Question about texture threads or cosmetic threads. Now, when you look at the hierarchy of what's faster than what, no threads is going to be the fastest, right? No image, no threads. Cosmetic threads is going to be the next one where you actually do the image on there. That's going to be the second quickest way, but there is a slight hit. Not much, but if you're talking 10,000 components, do you really need to see that either at that upper level? again, you can have a configuration that's simplified that doesn't have it. The next step up would be modeling them cosmetically and then actually modeling the threads fully. So, textured threads is a good alternative to actually modeling something for the threads itself. Okay, but if we're thinking large assemblies, that still may have an effect. Okay, I want to thank everyone for attending. Looks like we have all the questions. This will be is recorded and will be on our website for you to review. If you want the presentation, just email me, Kevin at